afternoon, Chairman and members of the Assembly. Thank you for having me. My name is Kuruntachalam Kanan. I work for the New York State Department of Health at Wadsworth Center. I am a research scientist, and I have been working on chemicals in the environment and also biomonitoring of chemicals in human beings for over 20 years.
Hi, thank you also for inviting me. My name is Dr. Julie Herbstman. I'm an epidemiologist by training, and I'm an assistant professor at the of environmental health science at the Columbia School of Public Health.
Can you possibly get a little closer to that microphone? Thank you.
Sorry, is that?
No, that's okay. Thank you. One of you care to go first?
Okay. First of all, I would like to thank you for your kind invitation to submit this testimony for today's hearing on flame retardants in children's products. The brominated flame retardants have been used in products for over 40 years, and now they are widespread global environmental pollutants. You can find them in polar bears. We have done some studies looking at these compounds in penguins from Antarctica, tissues of polar bears from Arctic Ocean, dolphins, whales, marine fish, freshwater fish. So these compounds are ubiquitous, which means that we have already contaminated the global environment. And once such contamination occurs, it's hard to clean up the environment because these compounds are persistent and they can get transferred from generation to generation. Yes, it was discussed before. These compounds can cross placental barrier. They can be found in umbilical cord blood. So from mothers to children, the infants, these compounds get passed. Same way, this is true for wildlife also. From dolphins, when they give birth to the young ones, the fetus of those dolphins also contain very high levels of these toxic chemicals. So you can find these chemicals in a wide variety of biota, including fishes, birds, in addition to human beings. And the levels in North American environment is at least 10 times higher than that found in European environment. And also in studies with humans, higher levels have been measured in children than in adults. And in children, the health concern arises from endocrine disruption and neurotoxicological effects. And these compounds, as I mentioned before, occur in umbilical cord blood, placenta, and also in fetal liver. Recent evidences also suggest an inverse relationship between the levels in cord blood and also neurodevelopmental outcome in children. So if you have high levels of PBDs in cord blood, you can expect that the children with high levels have lower neuro health or higher neurodevelopmental problems. We have also calculated exposure doses of PBDs by American infants and toddlers through breastfeeding, dust ingestion, and inhalation of indoor air. We have also measured these compounds in foodstuffs from North America, and you can find these compounds in all these matrices of human exposure. And the American infants ingest at least 10 to 100 times higher doses of PBDs than adults do. And the levels of PBDs in human milk from the United States are typically 10 to 100 times higher than the levels found in Europe as well as in Asian countries. And American infants are exposed 10 to 100 times higher doses of PBDs than European infants. Indoor dust from American homes and offices contain PBD levels 5 to 10 times higher than those found in European offices and homes. Ingestion of indoor dust is a major source of exposure to PBDs in toddlers and adults. Now, PBDs are persistent and bioaccumulative contaminants in the environment. The levels have been increasing in the environment at least until 2005, both in humans and also in wildlife tissues all over the world, with a doubling time of 2 to 5 years in North America. So every 2 to 5 years, the levels have been doubling. The voluntary efforts of U.S. industries phase out of penta-BDE and octa-BDE in 2004 appear to be effective in reducing environmental levels, as the levels of penta-BDE congeners in fish and biota in North America seem to be declining after 2006 for those particular types of congeners. However, if you take samples from recent years, you will see that the proportion of highly brominated congeners, like PBDE congener 153 or 183, are increasing in comparison with, in relation to total PBDE concentrations. This suggests the continuing usage of highly brominated PBDE congener, namely the deca-BDE. So it's my understanding that removing or reducing PBDEs from consumer products should, over time, reduce environmental as well as human body burdens of these chemicals. Children can be more vulnerable to the effects of exposure to toxic chemicals than adults, as Dr. Landrigan mentioned before. Therefore, eliminating or reducing the use of PBDEs in children's products should, over time, reduce exposures, body burdens, and associated health risk from such exposures. That's my testimony.
Thank you. Dr. Herbst? Yes.
Thanks again for the opportunity to speak to you. In addition to my affiliation with the Department of Environmental Health Science, I also work at the Columbia Center for Children's Environmental Health. And so the research that I do and that my colleagues at the Center for Children's Environmental Health do is we really look at prenatal exposure to a wide variety of environmental chemicals and look at the impact that that has on children's health and development. And my research focus has been on early life exposure to PBDE, so polybrominated diphenyl ethers, which you've heard about already today. I've been working on research related to the endocrine disrupting potential and the neurodevelopmental impact of PBDEs for the past 10 years, both in Baltimore, Maryland, and then here in New York City. In my research, my colleagues and I have measured PBDEs in umbilical cord blood of babies born in Baltimore and also in New York to approximate the amount of PBDEs that babies are exposed to when they're in the womb. And we have been able to measure them in the majority of cord blood samples that we've taken. And the PBDEs that we measure in cord blood, they really reflect the maternal exposure that's been transferred to her baby. So the only way that a baby in utero can be exposed is through his or her mother. Other researchers have shown that infants and children typically have higher levels of exposure than adults. And this is concerning, as we've heard from Dr. Landrigan, that children and developing fetuses, neonates, they're especially vulnerable to environmental chemicals for a variety of reasons, mainly that they don't have the same metabolic capacity as adults do. They're exposed to more chemicals for their body weight, and they're rapidly developing, and these developmental processes can be disrupted fairly easily. In the study that Dr. Landrigan referred to that we published in 2010, there were 210 women who we recruited at hospitals in New York City, and we measured their PBDE concentrations in umbilical cord blood. And then we followed their children over time and did neurodevelopmental testing, so IQ testing, behavior, things like this, over from 1, 2, 3, 4, up to 6 years. And we found that the babies that were born to moms that had high levels of PBDEs in their cord blood scored lower on their neurodevelopmental tests. This is among the first studies that have shown this association. I'd just like to point out that these studies take a long time to do, so it's not that easy to replicate just to go out and do it. But they are consistent with what we've seen in laboratory animals, where PBDE-exposed mice did worse on tests of learning and memory. We're in the process of confirming these results in another population of women and children in New York City, although it'll take a little bit of time to do. But in this new study, in addition to looking at prenatal exposure, we'll also be looking at the impact of postnatal exposure, because as we also heard from Dr. Landrigan, brain development doesn't stop at birth, and so looking at the effects of postnatal exposure in addition to prenatal is important. The approach that you all are taking to consider banning flame retardant chemicals like PBDEs in children's products is supported by the science. There are two things that I'd like to bring to the attention of this committee. First, that there's emerging evidence that some of the replacement flame retardant compounds that are now being used to meet the flammability standards are neurotoxic in addition to being carcinogenic, and exposure to these compounds therefore should be reduced. And also that children's products may not be the only or the most important source of childhood flame retardant exposure, so perhaps an integrated approach to reducing exposure could be used or considered. Penta BDE, so the Penta product, was one of the most commonly used flame retardants added to polyurethane foam. It was phased out in 2004, as we've heard. But in order to continue to meet flammability standards, other flame retardants, including TDCPP, which is a chlorinated flame retardant, has been used. And in laboratory studies, there's been indication that cells that are exposed to TDCPP exhibit similar adverse effects as known neurotoxicants like chlorpyrifos, which is a pesticide that's since been banned. However, in humans, studies examining the neurodevelopmental effects of these replacement compounds have not yet been conducted, and I'd like to take a second to tell you why. As we heard from the folks from the American Chemistry Council, they were saying how they were trying to keep up with the science. And I would like to put forth that we're actually trying to keep up with the industry. And I say that because even if I would like to do a study to look at the effects of TDCPP or other replacement compounds that are in the FireMaster 550 class, I don't know what they are, and I don't have tests that I can readily use in a scientific study. So that puts me at a disadvantage to try to give you the evidence to show that they're safe or they're not safe. I just can't do it. In addition, without this evidence, I would say that preventing exposure, given the laboratory studies that have been done, is really warranted and prudent. In addition, even as PBDE's production has been phased out, exposure continues through indirect contact from PBDE-containing products that are still in use, as you all have mentioned, and possibly through indirect dietary exposure once PBDE emissions end up in the food chain. So